This is one of my favourite topics to talk about, and the reason for that is it's something that you need to think about at the research design phase. So a lot of people bring their data in to have me give them a hand in terms of the analysis, and I look at the data and they tell me what tests they want to run with it, and it turns out often that the tests they'd like to run aren't possible simply because they haven't collected the right level of measurement. So when you are designing a research study, it's not enough to just design a bunch of questionnaires or whatever your data collection instrument is and hope for the best and worry about your data analysis later down the track. You actually need to be at the data or the research design stage thinking towards your analysis. And on a quantitative project, part of thinking towards your analysis will be thinking around what your levels of measurement are. So this is really, really important. Your level of measurement essentially determines what kind of statistical test you can run. So let's talk about the difference across these. So nominal is what we call the lowest level of measurement. Nominal variables are categorical, so it's kind of like putting people into boxes. But there's no order or mathematical reasoning to the categories. So gender and ethnicity are examples of a nominal level variable. It's categorical, you're putting people into boxes for those things, but you can't say that one group is more important than another. So for example, we can't say the men are more important than the females or vice versa. They're just boxes or categories. So that's the lowest level of measurement. There are some variables that have to be nominal. So something like gender, there's no other way around that. But ideally, when you are designing your studies, you want to have as few nominal level variables as possible because you can actually do very few statistical tests with them. So if you have to ask a question in a nominal format, that's fine. But if you have the option, the ideal scenario is that you have as few nominal level variables as possible. Ordinal level data is the next one up, and this is still categories, but there's an order to the categories. So an example would be high, middle, or low socioeconomic status. There's a sort of ranking or an order there, but you're still putting people into boxes. You can't say that the high SES group are twice as well off as the middle, or the middle is twice as well off as the low. It doesn't work that way. You're just sort of putting people into crude boxes. For those of you familiar with the New Zealand schooling system, decile, school decile, 1 through 10, is another example of an ordinal level variable. Now, at the top of this range of possible levels of measurement is scale. So scale is the best type of variable to have because you can do more statistical tests with it. And there are two types of scale variables, ratio and interval. The reality is, though, that both ratio and interval are treated the same in terms of any statistical testing that you might do. So while there is a distinction across these two, and it's useful to be familiar with the terms in case you see them in stats textbooks, as far as any statistical testing that you're doing is concerned, it doesn't matter whether it's ratio or interval. They're both just considered to be scale. And the key characteristic of scale level data is it's continuous data and there's an equal distance between data points. So the distance between a 10 and an 11 is the same as the distance between an 11 or 12. or the difference between 10 to 15 is the same as 15 to 20. So we consider there to be equal distances between the data points. Just in case you're curious, the difference between ratio and interval. Ratio level data has a 0 point, so time would be an example of that, 0 seconds up to 10 seconds. Interval level data doesn't have a 0 point, so there's still equal distances between the scores, but there's technically no 0 point on the scale. And my favourite example of this is IQ. So with IQ, it's a standardised test, and there are equal distances between the points. The distance between someone who has an IQ of 90 versus an IQ of 100 is exactly the same as the distance between an IQ of 100 to 110. Now, in terms of IQ, though, there actually is no 0 point on the scale. So you can't have an IQ of 0. No, we probably like to joke about that with certain friends and family on occasion, but technically speaking, on that particular scale, there is no 0 point.